Welcome to this explainer on navigating the revamped Cycle 1 proposal workflow for the Nancy Grace Roman Space Telescope. I am so excited to guide you through this material today because, quite frankly, Roman is going to completely revolutionize how we interact with space-based data. If you've proposed for Hubble or the James Webb Space Telescope in the past, you're definitely going to want to pay close attention here, because proposing for Roman requires learning a totally new structural language. Here is what's on the agenda today. First, the survey-first paradigm. Second, we'll meet the Roman APT. Third, we'll cover its powerful new features. Fourth, navigating the RTPS. And finally, getting ready for Cycle 1.
All right, Section 1, the survey-first paradigm. Let's dive in. So if you're used to the traditional point-and-shoot method used by Hubble or Webb, you know the drill. The goal is usually to look incredibly deep into a tiny, very specific patch of the sky. But Roman? It totally flips the script. It acts more like a panoramic scout, surveying these vast, massive swaths of the universe 1,000 times faster. It finds the absolute best needles in the cosmic haystack and maps them out so observatories like Webb can investigate them later.
To really put this into perspective, Roman's Wide Field Instrument, or WFI, has a field of view that is at least 100 times larger than Hubble's. Literally 100 times. We're talking about capturing a massive footprint of the sky in a single shot, all while keeping that crisp, Hubble-quality infrared resolution. You just cannot plan observations at this kind of unprecedented scale using the exact same manual methods you'd use for a narrow-field telescope.
Because of this mind-blowing scale, nearly 75% of Roman's 5-year prime mission is already blocked out for massive, community-defined core surveys. This is a huge shift, and it completely changes how you propose for telescope time. Oh, and here's a really crucial takeaway. There's absolutely zero proprietary period for Roman data. The second it hits the archive, it's public. It unlocks the science for everyone instantly.
Moving right along to Section 2, Meet the Roman APT.
So the Astronomer's Proposal Tool, or APT, has been totally revamped for Roman to handle this new workflow. Think of it like learning a new grammar. You start at Step 1 by defining your target or region. Then, Step 2, you build your past plans. And finally, Step 3, you sequence them into a survey plan. Because Roman is inherently a survey instrument, the tool is purpose-built to help you easily map huge areas of the sky or efficiently handle some really complex time domain observations.
Which brings us to Section 3, powerful new APT features. Okay, this is a real game changer. Instead of just picking a single fixed coordinate, you can now designate region targets. You literally just draw a polygon on the sky, and the APT's region planner steps in and acts automatically. It fills your shape with these optimized overlapping rectangles called tiles. You don't have to sit there and calculate every single pointing manually anymore. It's going to save you an incredible amount of planning time. Once your region is all set up, you build out your past plans. This is the core architectural block of your observation. It's where you tell the telescope exactly how you want it to capture the data within those tiles. So this is where you lock in your exposure times, you pick your filters, and you define your multi-accumulation, or MA tables. Those MA tables basically tell the telescope how to group the infrared detector reads before beaming all that raw data back home to Earth. And for the final piece of the puzzle, you string those individual passes together into a complete survey plan. This is really where the magic happens for advanced science. Say you need a specific positional angle, or maybe you want to run a time series where observations have to happen exactly 5 days apart to look for transients. You apply all those special linking and timing constraints right here, using the built-in visit planner to make sure your complex observations can actually be scheduled. All right, Section 4, navigating the RTPS.
When it's time to submit, you'll use the Roman Telescope Proposal System, or RTPS, and you can actually put your calculators away for this part, because the RTPS uses a highly streamlined single-phase submission process. You get to completely skip the detailed budget forms. There's no need to spend hours agonizing over line item budgets during this initial phase. You just select a funding category. Small, medium, or large. This lets you stay totally focused on what actually matters, crafting the absolute best science case possible.
Now, you must carefully ensure that all PDF documents you upload into the RTPS strictly adhere to the Dual Anonymous Peer Review, or DAPR, guidelines. This is absolutely vital. The evaluation process is strictly anonymized to guarantee that proposals are judged purely on their scientific merit and not on the names or the institutions attached to them. You will submit your non-anonymized team expertise in a completely separate, dedicated channel, but that core science PDF has to remain totally anonymous. No exceptions.
Finally, Section 5. Ready for Cycle 1. As we get ready for launch, keep in mind that while a small handful of new observing programs will be selected, the vast majority of Cycle 1 funding is actually expected to support the analysis of data from the existing core surveys. Remember, 75% of the telescope's time is already spoken for. So the strategic move for most scientists is to apply for funding to analyze this massive, incredible treasure trove of public data. Cycle 1 is really your gateway to getting the resources you need to dig right in.
Over its lifetime, the Wide Field Instrument is expected to measure the light from literally 1 billion galaxies and find thousands of exoplanets. It's almost hard to wrap your head around. The proposal tools are ready, and the data is going to be open to everyone from day one. So, with this entirely new paradigm of panoramic data headed your way, the only question left to ask is, how will you use 1 billion galaxies to advance your science?